Number 16 and 17. An object of mass 3 kilograms starts from rest and moves along the x-axis. A net horizontal force is applied to the object in the positive x direction. Force time graph is shown below. Number 16, what's the net impulse? The net impulse delivered by the applied force. So on a force versus time graph, the impulse is going to be the area under the curve. So it looks like we have a rectangle. And its area would be 4 times 6, so that's 24. And we have a triangle. Half the base would be 1 times 6 would be 6. So it looks like adding up the 24 plus 6 would give us a net impulse of 36 kilograms meters per second, which is equivalent to 30 newtons per second. What's the net work done in the object by the applied force? All right, so well, we know that impulse equals a change in momentum, which equals mass times a change in velocity. We know that work is equal to a change of energy. In this case, it would be a change of kinetic energy. So we can say work, well, let's go back. So we can say impulse equals mass times change of velocity, or velocity is going to be equal to impulse divided by the mass. The impulse we figured was 30 divided by a mass of 3, which gives us a change in velocity of 10 meters per second. So work is going to be equal to a change in kinetic energy, which is 1/2 m change in velocity squared. So 1/2 the mass of 3 times a change in velocity squared. 100 times 3 is 300. Half of 300 is 150 joules of work.